Hi, y'all. Okay, so what we're going to do today is we're going to figure out how to find missing sides and angles of a right triangle using trig. Now, in the last couple of slides in your slideshow before you got to this video, I told you all about sine, cosine, and tangent and how to remember them using SOHCAHTOA. And so now I'm going to show you how to apply those. Now, if you see all my scribbles here, I started another video just a minute ago, and had to stop and erase it because my calculator was out of whack. So that led me to something else that I need to show you as well. So let's get to it. I got a lot to show you here. All right, so in this first one, it says find the measure of each angle indicated and round to the nearest tenth. So I'm looking for the angle indicated, and in this case, that would be this angle right here, angle A. It's indicated by this little theta symbol. So that means that we're going to try to find what this angle A would measure by using the theta, and we'll use either sine, cosine, or tangent, and then using these two sides. All right, in a 90-degree triangle, which is what we have in all of these, across from the 90-degree angle is the hypotenuse. And then from the angle that you're working with, in this case, like I said again, this is angle A is what we're working with, we determine what this side is. If it's across from the angle you're working with, it's opposite. But when it touches the angle you're working with, it's adjacent. So we have opposite and adjacent. And so is it sine, cosine, or tangent that uses hypotenuse and adjacent? Well, sine is so, like in SOHCAHTOA, S-O-H, sine equals opposite over hypotenuse. Well, we have adjacent and hypotenuse. So cosine, C-A-H, is cosine equals adjacent over hypotenuse. Well, that's what I have. I have adjacent and hypotenuse. So I'm going to be finding the cosine of theta. Cosine of theta equals the adjacent over the hypotenuse, which in this case would be 12 over 13. So cosine theta equals 12 over 13. All right, now I simply solved for this by using my calculator. Now, the problem that I had with my calculator just a minute ago, oh, there's my answer. The problem that I had just a minute ago was my mode. Now, if you have this kind of calculator at home, you need to know this. On the state tests, you're going to be using Desmos, and I'll show you in a meeting how to find this on Desmos. It's really easier there than it is here. So, but on this calculator, I would have to go to mode and make sure that I'm in degree. Almost always your calculators are set on radian. Here's another one I'm just going to grab randomly, and I haven't even checked it. This is my own personal calculator. If I go to mode, well, this one just so happens to be in degree as well. But usually they're always just set in radian. And so that's what I was up against a minute ago. I kept getting the wrong answer, and I was like, what in the world? And then I remembered you have to set it on degree. So just go to mode and make sure that degree is highlighted. All right, then what I'm going to do is when I have cosine theta equals something, I'm looking for what the cosine theta is. So I can't just put in cosine theta of something because I don't know of what. So what I'm going to do is I'm going to find the inverse of that. I'm going to say second cosine theta gives me cosine to the negative 1. And then I'm going to put in 12 divided by 13. And I get 22.6. And it does say round to the nearest tenth. So angle A equals 22.6. So this is all about the calculator. It really is. It's just all about knowing how to set up the problem. That's first, I guess, and then it's all about the calculator. So let's do some more so we can see how we set these up. All right, here we have theta, so that's indicating angle A. They can't get it any closer because the angle gets so small. But we're talking about this angle, angle A. And so across from the 90-degree angle, we have nothing. So we don't have a hypotenuse this time. This would be the hypotenuse, but there's no number. So we have opposite and adjacent. Opposite angle A is over here. And then touching angle A is right here, so that's adjacent. Remember, adjacent touches, opposite is opposite on the opposite side. That's the easiest one to remember. Okay, so I have opposite and adjacent. That would be tangent. Tangent, go soka your toa. Toa, T-O-A, tangent equals opposite over adjacent. So the tangent of theta equals opposite 4 over adjacent 13. So I do exactly the same thing I did last time, except this time I do it with tangent. So I say second tangent, that gives me the tangent inverse, or tangent to the negative 1, and then I put in 4 divided by 13, and that's 17.1 when I'm rounding to one decimal place. So angle A equals 17.1 degrees. I should put the degree sign. All right, let's head on down to number 3. Here's the angle indicated, angle A. And so I'm going to look for the hypotenuse first, because it's the easiest to find. Across from the 90-degree angle is the hypotenuse, and I do have it this time. I have the hypotenuse, so that's what I'm going to use. And then from angle A, do I have the opposite or do I have the adjacent? I have adjacent because it's the one that is not opposite, not across from. So adjacent and hypotenuse is going to be cosine again. Cosine equals adjacent over hypotenuse. Cosine of theta equals adjacent 6 over hypotenuse 9. So to get the cosine theta, which will give me angle A, I type in the opposite second cosine of 6 divided by 9, hit enter, and that's 48.2 when I'm rounding. 48.2 degrees. Okay, and let's do one more. I'm trying to find one where we're going to use sine, but I don't see one. No, I don't see one where we're going to use sine, but sine is always opposite over hypotenuse. Now, it's not saying that we're not going to use it. I'm just not seeing one where we're going to use it right offhand. I can do one. Let's make this one. Let's say that this is the angle we're looking for. We're looking for angle A. This is the one that's actually marked, but I'm looking for this one just for my sake. So I'm looking for angle A, and I have opposite and I have hypotenuse. So I'm going to say sine of theta equals the opposite, which is 4, over the hypotenuse, which is 5. So putting that in the calculator, I would do second sine and then 4 divided by 5, and that's 53.1. 53.1. Angle A equals 53.1. All right, this is a 90-degree angle. So I'm checking my answer here. I'm going to say 90 plus 53.1. That's 143.1. And then 180 minus 143.1 would give me, let me just use a calculator so I don't get it wrong. 180 minus 143.1, 36.9. 36.9. So now that's got to be angle B. Well, I'm sitting on top of the answers here. So number 6, angle B, 36.9. So we were correct when we found the other one. And we checked it by using the triangle angle sum theorem, because we know that they add up to 180. Okay, I'm going to show you how to find the missing sides, but I'm going to stop this video and then I'll come back and show you how to find a missing side next.